Decoding the atom. Delving into atomic architecture. Introduction. The discovery and understanding of the atom's structure have revolutionized our comprehension of matter. Throughout history, scientists have explored and refined the atomic model, enabling us to grasp how the atom's fundamental components influence chemical behavior and the properties of the surrounding matter. Atomic models, timeline. What is matter made of? 1803. First atomic theory. 1897. Discovery of the electron. 1911. Planetary model. 1913. Jumping electrons. 1920. Quantum atomic model. 1927. Current atomic model. Importance. The role of atomic structure in chemical reactions and energy technologies drives innovation across various scientific disciplines. The atom's structure shapes the behavior of matter, underpinning current chemistry, physics, and technology. Understanding atomic structure unlocks perspectives on matter's properties, propelling scientific advancements. What is an atom? The atom is the fundamental unit of matter. It consists of a central nucleus, containing positively charged protons, and neutral neutrons, surrounded by a cloud of negatively charged electrons. The interaction between these particles determines the properties and behavior of chemical elements. What are its components? Electron cloud. Region around the nucleus, where electrons orbit. Atomic orbitals. Three-dimensional regions, where electrons are most likely to be found in an atom. Electron. Negatively charged subatomic particle orbiting the nucleus. Neutron. Neutral particle in the atomic nucleus alongside protons. Atomic nucleus. Positively charged center of the atom containing protons and neutrons. Proton. Positively charged particle in the atomic nucleus. Particle-to-mass relationship. 1. Mass comparison. The proton-electron mass ratio indicates that protons and neutrons are much more massive than electrons in an atom. 2. Impact on atomic mass. The electron's mass is negligible compared to that of protons and neutrons, predominantly determining atomic mass. 3. Effect on chemical properties. PEMR influences chemical properties by affecting electron attraction to the nucleus, thereby influencing reactivity and chemical bonding. What is electron configuration? The arrangement of electrons orbiting the nucleus is referred to as electronic configuration. The electronic configuration dictates how an atom interacts with others, influencing its ability to form chemical bonds and engage in reactions. This understanding is crucial for explaining the properties and behaviors of elements in the periodic table. Electronic configuration. The diagram shows the number of electrons per level, with the respective orbital name and its energy sublevels. Conclusion. The structure of the atom, understood through its components and their relationships, along with electronic configuration, forms the foundation of our understanding of chemistry. This knowledge has enabled us to unravel the secrets of matter and create technologies that enhance our lives. Thanks for watching.